Hello. Now that we've written and compiled our shader code, we can look into loading it in our program. I'll go into the header file and create a new function called createGraphicsPipeline. The graphics pipeline creation will take up a few lessons, and in this one we will start with implementing the createShader module. It takes a span of bytes and returns a vkshader module. I then go into the CPP file and scroll to the presentation region. Here I create a new region called Graphics Pipeline. And inside it I will paste our create shader module method. Next I create a body and I will also add the create graphics pipeline function. The pipeline will be created in the initialize Vulkan method on the bottom as well. Now in the graphics pipeline we need to call the create shader module to create our vertex shader. But we first need to read our SPIR-V file into bytes. So let's go into the utility header file and create a new function. It will return a vector of bytes and will be called readFile. For its parameter, it will accept a file system path. So I also include the file system header file. I will then implement this in the CPP file. I paste the signature and create the function's body. We'll first check if the file system path exists. If it doesn't, we will return an empty vector. Next we can check if it is a file and again an empty vector if it isn't. And finally we can include the fstream header and use the input file stream to open up the file with this shader path. We open it up as a binary since we are reading bytes and not text. If the file cannot be opened, we will quick exit. Otherwise, we will create a char-sized buffer and then check the file size. We can do this by calling the sd file system and then file size. We can call file.read passing the buffer data casted to char pointer and the size of the file. Actually, we're returning uint. And we also need to reinterpret cast this. Finally, we return the buffer. Back here in the graphics implementation file, we can now create the vertex data byte vector by calling our readFile function. We can pass the path to the SPIR-V file. And then we pass this byte vector to the createShader module function. I will duplicate this code since we will also need it for the fragment shader. And I renamed their variables to reflect that. Now in the createShader module, we will test if the shader data has any size and is read. If it is empty, we will return a no handle for the shader module. To create a shader module, like everything else in Vulkan, you need a shader module create info. We set the S type correctly. The code size will be equal to the buffer size. The pointer to the code is actually a pointer to a int32 array. So we need to reinterpret cast the buffer data pointer. And we cast it to a uint32 pointer. We can now create the shader module. We can do this by calling vk create shader module by passing the logical device. Address to the info, no allocator, and an address to the shader module variable. I will also create the shader module variable above this function call. This one we will not need throughout the application. We can check if the result was a success, and if it wasn't, we will return a no handle. Otherwise, we return the created module. Here in the create graphics pipeline, we will also create a final action. The shader module is local only to the creation of the pipeline, and we will need to destroy it after this function ends. So I create a final action called destroy vertex. In the lambda which captures the vertex shader, we will call the vk destroy shader module. This function needs the logical device as well though. So I will add this to the capture list. We need the same code to destroy the fragment shader as well. So I duplicate it and correct the names. We can now build and run this code to see if it works correctly. And this time we get an error when creating the shader. I open up the terminal to read the message. I'll stop the debug mode. And this is the most common error that I do with Vulkan code. When having an info object created, do not forget to initialize it to 0. Now I can build and run this, and there are no issues seen in the console. This should pretty much conclude the shader creation. I'll add a bit more code here though. It is good to validate that both shaders are actually created and not no. In the case they are both no, we can exit the application. To load the shaders into the pipeline, we'll have to create two shader stages. The shader stages will load the shader modules. We first create the vertex shader stage, set the S-type correctly, set the stage to the vertex bit for the vertex stage, and set the module to the vertex shader module that we created. We also have to set the name of the main function, which is just main. I will duplicate this code for the fragment shader, where I change this to be called fragment stage info. And I set the shader stage fragment bit. We also need to pass the fragment shader as the module. And since we will be passing both of these infos together later, we can create an array out of them. So I create a new stage infos array variable with the vertex and shader stage infos. This is it for this lesson. We learned how to load our vertex and fragment shaders into Vulkan, ready to be passed to the graphics pipeline.